Okay, welcome. This is going to be an update on NitrOS-9 on the Foenix F256 computers. Uh, I'm a very recent owner of one, which I got last year. We have Boise who's watching back there who ported OS9 to it. We have Massie and John Federico who's been doing a lot of work with it, been more than me. Uh, they volunteered to help with this presentation, and they got this set up so well. I'm going to let them do most of it, but it's a very interesting machine. It runs 6009 code. Basically, I look at it as a Commodore 64 on steroids, the 6009 processor installed into it. And so it's a very nasty machine, 6809 code to work with. And John, we'll let you go. I will show you the one machine here. There's like 4 different machines, is that correct?
Yes, it's 4 machines. Yep.
And so, as here you can see, it looks like a Commodore 64, pretty much. And it's hard, 6809 code. Cool. And so I'm going to be supporting the software and some hardware as well, as the joystick natively takes 3 buttons, so I built one. That's a 3D printer designer, so we're going to have that as well. And John, I'll hand it to you now.
Okay, great. You want to hear me? All right, so my name's John Federico. I'm here with Matt Massie and John Strong. And we're going to talk a little about the update to what's going on with NitrOS-9 on the Foenix F256 computers. And so today's topics, we're going to talk about the model overview for those of you who don't know what the computer is and what features are in it. We're going to talk about some of the dev tools, the FPGA tools you might have to use. Then we'll talk about the main features of the computer, and then we'll talk about NitrOS-9, including the current status and bitmap commands. We'll talk about the keyboard, mouse, and SD card, fonts, drive wire, and then what still needs work. And then I'm going to turn it over to Matt, who's going to talk about some Basic 09 additions that he's done. He's done a lot of work trying to get everything to run in Basic 09, and it's been absolutely outstanding. So, a little bit about myself. I got my first color computer probably around 1980. I had a color computer 1 with 16K of RAM. I got it upgraded to 64K, eventually got a CoCo3, and then right about before COVID hit, I got back into it. Now I also own 2 color computer 2s with a CoCoVGA and a CoCoD, and Sloopy's drive wirelessly, and also a CoCo3. And I was at Tandy Assembly a couple years back talking to Boise, and he apparently thought I didn't have enough stuff to annoy my wife with. So he said, you should get one of these Foenix computers and help us out. So that's how I got involved with the Foenix project. So the Foenix F256 computers were created by Stephanie Allaire up in Canada. There's actually 6502, 65816, and 6809 versions. On the 2 new ones, there's some chatter about maybe making a 68,000 core for it as well, so it could end up being 4 processors that are supported, but we'll see. I'm not going to hold my breath just yet, but it could happen. There's currently 4 different computers. So there's the F256 Junior and the F256K. Those are sort of the older models. The 2 new models are the F256 Junior Junior and then the F256K2. And there's been some pretty serious usability improvements in terms of FPGA and massive feature upgrade as well. So those are sort of the big 4 models right now. Why use the 6809 version? Well, first of all, it's got a 6 megahertz 6809, which is pretty fast. It's nice to use. There's 512K of RAM. We may get a RAM upgrade in the near future. We'll have to see on the Junior Junior and the K2. There's a possibility for 1 or 2 megs of RAM, so we'll see if that actually materializes. And NitrOS-9 runs on the F256 6809 computers, which is fantastic. And the memory map and MMU are similar to the color computer. They're not the same, but they're pretty close. And as a result of that, console text-based programs actually run unmodified between the Color Computer 3 and the F256K. So you can take like the Deer program off of a Color Computer 3 and it'll run on a Foenix F256. Likewise, if you take a console program and you compile it in CMOC, it'll run the same binary will run on both machines. So it's actually pretty nice. Another reason to use it is because it's got the same tooling you're used to on the color computer. It's basically the exact same tool. So you've got LW tools, you've got Toolshed, and then the Foenix Manager is the only thing that's different. And the Foenix Manager you use to load the flash ROM, and I'll talk about that in a minute, what the flash ROM is, or the flash is. And then all these are available through Henry Strickland's CoCoShelf. So if you have CoCoShelf, you can just clone that off of GitHub, compile it, and all the tools you need to develop on the Foenix are right there. And again, it's almost the exact same tools that you have on the color computer. There's also a MAME-based IDE in development. It's not quite done yet, but we look forward to seeing that be completed here in the near future. Okay, so there are different FPGA tools depending on what version you have. So if you have an F256K or a Junior, you have to use Cordis and a USB blaster to update the FPGA, which is a miserable experience. Cordis is like, I don't know, 11 gigabytes or something you have to install, and you just have to download this massive program. Then you have to get all the drivers working. You need a USB blaster, and also on the K and the Junior, the 6809 is a separate chip. So if you need to upgrade the 6809, you're actually upgrading the FPGA on the board, and then you have to upgrade the FPGA on the chip as well. So the new ones massively improve that. On the K2 and the Junior, there's just a USB port in the back of the Junior, and the USB port, there's actually 4 ports on there. There's a serial port, a debug port, and the FPGA program port, and maybe a second serial port.
Expansion port.
Oh, expansion port. So there's 4 ports on there. So all you need to do is plug the USB cable in, plug it into your computer, run OpenFPGA, and you can upload you can update the FPGA right away. So the new ones really have a much better usability from that standpoint. So some of the main features of the F256K. So the graphics are pretty extensive. So you can have up to 3 bitmaps. There's 3 different layers. So there's 3 graphical layers, and then there's 4 sprite layers. So, and there's like a sprite layer, then a graphics layer, then a sprite layer, then a graphics layer, then a sprite layer, then a graphics layer. And so on the graphics layers, you can either display a bitmap or a tile map. So if you're just displaying bitmaps, you could theoretically, put 3 bitmaps on the screen at once, as long as they had some transparency in there to see through. Same thing with the tile maps. The tile maps are layered, so you can either have a bitmap or a tile map. The resolutions are 320 by 240. If you're running at 60 hertz, or if you're running at 70 hertz, it's 320 by 200. All right, so there's 4 sprite layers. Again, you can have 64 sprites total. You can have different resolutions for the sprites. You can have 8 by 8 all the way up to 32 by 32. And then the text modes are all either 80 or 40 columns across. And then you've got choices of either 60, 30, 50, or 25, depending on whether or not you're running in 60 hertz or 70 hertz mode. We usually run everything at 60 hertz, so we're usually running in either 80 by 30 or 80 by 60. There's SD cards. The external SD cards work on all machines. The internal one we don't have a driver for yet, but we're working on that. Actually, Boise's working on that, I should say. But we think we'll have that'll be done pretty soon. There's lots of sound options. There's a PSG, there's dual SIDs, and there's OPL3 on the Junior and the K2. The SIDs on the Junior are you have to actually have the chip. They're not built into the FPGA. They're not soft SIDs. You have to have the actual SIDs. And then on the K, there are soft SIDs as well. You can have up to 4 Nintendo joysticks and 2 Atari joysticks. So if you need joysticks, you've got lots of options for that. Most of those, there aren't directly ports, but there's a header for it. And there's an external box you can get that plugs into that gives you all the joystick capabilities. Everything is PS2 keyboard and mouse, although the K2 has an optical keyboard on it now, which is actually supposed to be pretty nice. I haven't seen it yet, but it looks nice. You have a serial port. You've got DMA timers. All of them output DVI, so you can hook them up to a normal monitor. There are HDMI ports, but they're not HDMI. It's just the DVI signal coming out of the HDMI port. There's an integer math coprocessor or a processor built into the FPGA, so you can do 32-bit math really easily, which is nice. Or integer math. There is a real-time clock, so that's also pretty important for a lot of people. And then there's a MIDI chip. It's the Dream Sam 2695. That's on the Junior and K2 only. There's an MP3 decoder chip on the Junior and the K2, but not on the older machines. There's a WIZ-Fi 360 on the Junior and the K2. The WIZ-Fi 360 is a wireless chip, and it works like a haze modem. So you send it haze modem commands, and it does everything else for you. On the K2, there's a wired Ethernet option with a Wi-Fi 6100, which is a little bit more raw. And then on the K2 also, there is an FPGA management system on there. So you can actually load up the cores into the K2, and you can switch between them on the fly. You don't have to hook it up to your computer. There's actually an RP2040 or some variant of it on the board, and that will actually load the FPGA for you. So if you were running 6809 mode and you want to run in 68000 or 6502 mode, you can just hit a button, restart, and it'll be that way. Everything else you have to hook it up to a computer and run some kind of FPGA loader to do it. There's also a MIDI interface on the K2, and then of course there's a serial port. Okay.
So quite a sensitive system.
It is, and and just to kind of show you briefly, let me shift over here real quick. We're gonna get it.
You're going to get it.
I'm on 3, right?
You want it on 2.
Oh, 2. There we go. So
It's coming.
I've got a brief demo of let's see if we can get this to work. Music. See if it pops up. There we go. So what this is just a simple demo program. I want to show the fact that you can have 3 different bitmaps showing at once with 3 different color layers. So there's actually 4 color lookup tables you can use. I'm using 3 of them here. So this is an image with 1 lookup table. This is an image with another lookup table. This is an image with a third image with the third lookup table. These are all on different layers. Each one is just a third. So this is like the first one's a third of an image with just blackness afterwards. There's the middle one's got here with its transparency top and bottom, and then this third one down here is just this, and it goes up. But you can see, you can actually have 3 different graphics layers plus a layer of text on top, and you can control whether the layer of text on top is there or not. So, let's leave that up for a second. Let's go back to the slides. That's where I have to hit it twice. I hit it twice initially. Okay, so the newest versions are the, let's see if that pops, it's going to pop back up.
Yep, it's coming.
There we go. So the newest versions are the Junior and the F256 K2. The Junior is just a single board computer. It's really tiny. We'll have them at the booth. If you look at it, it's only about this big. It's pretty neat. There's a lot of hardware on there, and it's about $245 for that. I think that's probably one of the best deals right now out there, considering the amount of hardware you're getting. You're getting, a Wi-Fi 360, the MP3 chip, the Dream chip, 4 different sound chips, plus all the graphics layers. Plus, you're getting a 6502, a 65816, and a 6809 capability on one board. So I think that's a pretty good deal. The K2 is a little more pricey. It's $595, but you get a lot of hardware too. I mean, you get an optical keyboard. It's an all-in-one unit. You get MIDI ports. There's some other extra ports on there that I forget what they are at the moment, but there's a lot of stuff there. So the advantages of the new machines over the old ones, there's more features, and then it's easier to upgrade. And really, you're getting a combination machine. On the old machines, on the K and the Junior, the 6809 was a separate chip. You actually had to install the chip. This one you don't have to. There's a 65816 on board on each board. Plus you have the FPGA, and then the 6809 works with the FPGA. Okay. We do have some. No, I didn't miss the slide. So NitrOS-9 on the runs on the F256, and there's sort of 2 different versions of it that are running on there. The first one is the FOU, which is the Foenix Executive Utility, or the Foenix first execution unit. So, but that's actually NitrOS-9 level 1, and that's what's going to be left. So if I flip back over to Foenix here. So I've got the computer up here. So if I turn the computer off and then I turn it back on again, it should reset. You can see when this pops up, little videos. So you can see it boots up pretty quick. So we've got NitrOS-9 right here. Turn it on. There's 512K of flash inside the machine. And so when I turn it on, it's actually going to boot into level 1. And level 1 is actually the bootloader for the machine. So you'll see it pop up here. This is actually level 1. This is the boot. This is the Foenix executive boot. So you can see I've got different options here. I can boot OS9. And if I try to boot OS9, it'll let me boot the cartridge, the SD card, or drive wire. And then you've got a debugger, and you can also get into the shell if you want. And you can see here, all this stuff in the boot is based off of text files. So if you boot.zip, this goes into the options that I get for the main list, you can see this. So that does that. But if I stick a flash card in there, level 1 will see the SD card, and it won't give me this menu. It'll just shoot right into the computer. That's 2. Obviously, boot off. SD card is also has to boot off there. All right. All right, we'll give that a second. But the next thing I want to talk about was what works on the system. So we've got a bootloader, we've got the NitrOS-9 runs, we've got the SD card, the keyboard, and works as well on all machines, so that's nice. And then we've got different drivers for different things. So one of them is we've got graphics drivers that really just give you kind of access to the system that gives you what you call directly from NitrOS-9 to access the graphics capabilities of the machine. A great driver. So while Matt does that, so there's a couple of things we did. So the graphics capabilities we did are pretty good. I can show you one demo real quick. Get back up here. So to give you an idea of sort of the capabilities of this, this is on the Living World demo. This was a demo done by Dale on the Discord for 6502 side of things. And we just got permission from the artist to do this, and we just ported it over real quick. Here's the demo. And so this is loading the full bitmap right off the SD card. And it cycles through the palette to make it look like it's loading. You can see we've got a couple different scenes in here. I'm going to show you sort of the graphics capability and what's possible with this. The mouse driver also works. So the mouse driver is right here, and the mouse driver will auto-detect whether or not the PS2 mouse is attached. So if it's not attached, it won't load the interrupt. So that's kind of nice. The mouse will also auto-hide after about 6 seconds. So if I just leave it there, after about 6 seconds, it'll auto-hide. And then it'll just move the mouse to make it show back up here. Another thing we added was we changed the fonts around a little bit. We did some work with the fonts. So with the fonts, what we did was we put all the fonts inside of sysfonts. We made a new directory for sysfonts. And we put the fonts in there. We used Micah's fonts. Micah is one of the members of the Discord. He made a bunch of fonts for the 6502 side. We took those, brought them over to this one, and then all of the banner characters we put in characters 0 through 31. And what we did is we added a special call into the VTIO, which is 1C, I think, as a command code, so that we could get to those lower characters. Because normally if you do any character between 0 and 31, it's actually a command code that will do something with the display. So if you do a 1C, it's an escape code, so we can get these codes. All the fonts have that, and so we can do different fonts. Now I wanted to have a font selection program, so I wrote one, and then I wanted to be able to display 2 different fonts on the screen at a time, because you can there's actually a font 1 bank and a font 2 bank in the hardware. You can only display one on the screen at a time though, so the way to do that was there's a start of line interrupt, where you can get the raster line interrupt down a certain page. So I wrote a driver for that. So all you have to do with the driver is really simple calls. You just open a path to the driver, to the start line driver. Once you do that, you say, I want you set me this interrupt when it gets to this line, and then it'll just send you the interrupt, and you just handle the interrupt. So I did that on, oh, it's all right. That's okay. Now I want to go back to this. It's okay. We're good. Back up. So this is the font config program. And so what this lets you do is when you pick a font, the font here is the main system font, whatever you're using right now. This font is the font that you want to preview. So it actually loads these off of the SD card from that fonts directory, and you can see, for example, the boxed font is very different from the Apple font. And then on top of that, I set it up so you can pick a color. If I want green foreground and a black background, this will give you a preview of what it looks like. You can also switch resolution, so I can go between 80 and 40, and then I can also go between 60 and 30. So if I want to go to 60, I'll just go here, and then I hit return, and then I get this, and then you can see I've got all that. If you run it again, it'll remember all the settings except for the font. So I've got to work on that still, but I can change it to the 2-ish font. I think is pretty good. I'm going to go back to 30 this way. But the start of line driver was important because it's one font down here. The interrupt happens. I change the font. The interrupt happens again here, and then it goes away. The other thing I added at the start of line driver was a mute call, so you can mute all of the interrupts temporarily. So when it loads the font off the disk, I was getting a lot of flashing. So I just muted it, loaded off the disk, and then it goes. So that is it. We also have some graphics utilities. Back up. Hey, we're back. So we've got F status, which is a command line to output the stats to the graphics registers. It's really good for debugging. We've got a line, we've got a pixel command. The only reason why I put this here is I came up with this more complicated algorithm because there's 76,800 pixels on the screen, which is more than 16-bit value. So I came up with this way of dividing it in half, because at the 5th block it starts at 0 again, so I can get the block number and the offset to map that in to put the pixel on. And Gadget on the forum said, no, don't do it like that. And Gadget ended up using the carry bit as an extra bit for the math, so I could actually we could do that without having to do that. Gadget had some other math tricks as well. So that
John,
goes.
I'm going to interrupt you there
Sure.
just a moment. That actually, I've looked at that a little. Probably could be improved a little bit better than that.
Okay.
You can probably eliminate the multiply and the rotate.
Okay.
I will be checking that out and verify that when if I get that work done, I'll get that to you.
Okay.
So.
No, that sounds good. That sounds good.
Yeah.
So we talked about the keyboard and the mouse. We talked about the fonts. We've got these are the calls for the font loader and for the you load a font and also get a change a font character. You can get or set a font character. Talked about the SOL driver, DriveWire and networking. Roger Taylor's been working on the Wiz5 360 driver, and he almost has it working. So we're looking forward to having that and actually being able to do DriveWire over the wireless on the Junior and K2. And then the real-time clock does work, so that's fantastic. Finally, what still needs work? What don't we have? We don't have multiple terminals yet. So if you're used to NitrOS-9 level 2 on the color computer, you hit the clear key and get a different terminal. We can't do that yet. One of the things we're waiting for is DMA. So there's on part of this big Endian update to the FPGA, we've restructured some things and we're waiting for the DMA to come back. And so once we have that, I think we'll probably be able to do multiple terminals. One of the issues is the screens. We probably need like 16K a screen because we've got 4,800 characters for 80 by 60, and then you've also got a set of colors that go along with that. So it's 4860. So you get 9600. So that's the only caveat there. You still need to write drivers for a lot of the hardware, but even without drivers, you can still manipulate the registers manually. It's just that you're going to run into multi-processor issues if you have two processes that are doing that at the same time. We probably need different memory management because if we get more than 512K, all the graphics have to exist in the first 512K for the FPGA to see it. So the bitmaps, sprites, tile maps, all that has to be in the first 512K. So we're going to probably have to add a VRAM flag. There's actually one in there already, but we're probably going to have to use it and come up with a couple different calls for that. We need more configuration utilities. We'd really like to get some dev tools to be able to develop directly on the machine, like a C compiler and an assembler. And then we need more documentation, and we also have to update the GitHub. We've been kind of negligent about that in the past month and a half, 2 months, and we need to update some stuff on that.
I'm going to comment here there because the difference between the F256K and the Junior and stuff, the mouse driver doesn't work properly on that. I'll be looking at that. I'm going to also work on some of the other stuff based on the work they're going to do when they get shared with me to make sure it's going to all work on the F256K. And so my background is graphics and stuff, so I'm looking at some optimization stuff, things I know to do that they wouldn't obviously see, just because I've had some experience with it. I have assembled some stuff already natively on the Foenix, so we're going to work with that and maybe extend the symbol table for ASM for OS9, because 8 is just simply not enough with all the things we have to describe and have symbols for the hardware to make sense to you. And so there is source out there on the NitrOS stuff for the SM, and so I've already started looking at that to see what needs changes in. So we extend that a little bit to make that. So we want to make this both you can cross development, and I definitely want where you can do local development. So if you buy one of these, you can go into like the CoCo. I'm not going to have a Linux machine to use it. I'm not going to have a Windows machine or whatever to use it as well. At least that's part of my goal, to help add value to the system. Back to you, John.
Thanks. And so, that said, everything that we've done so far with NitrOS-9, Matt has been adding calls at a furious pace to Basic 09, so that we can do everything through Basic 09. So I'm going to turn it over to him, and he can talk a little about the work he's been doing with Basic 09.
All right. So, getting started out, OS9 level 1 was my first thing on the CoCo, and I just loved it. It really helped me with Linux and everything else that I did. About 2019, really got interested in the CoCo, picked up some CoCo 3, some other stuff, MPI, CoCo SDC, etc. But I love it. But I never really got the new CoCo that I was waiting on. So about October of 2023, I heard about the Foenix from Boise and started learning about it. The Foenix 6809 FPGA for the 6809, the Tiny Vicky, which is all the magic within the Foenix system and how we're interacting with hardware. I had to learn about the MMU, bitmaps, sprites, tile maps, OS9 assembly and doing calls, and getting familiar with CoCo Shelf so that I had the tooling that I needed. But even yet, you look at it and we're sitting on a black screen with white text, and it was like, okay, that's where I want to come in and do something. So we wanted to have a look and feel. The 6502 community already had a look and feel, and it looked pretty good. So when we started doing stuff, we started playing around with ASCII art, and it really just didn't cut it. but it really helped me form how I wanted the logo to look. Then I went to like a block, solid block type font and started doing it. You can see on the basic on the bottom, it's really blocky. So what I wound up doing was making custom font characters, which we then had to adjust for all the fonts that are in the system. But what we wound up with is a pretty nice looking logo with drop shadowing and the whole bit. And that's nothing but text. It's nothing but text because we had no graphic drivers when we were doing this. So this is what Basic 09 looks like. And I'm dropping into the background some of the other stuff that we're doing. But essentially, you get the idea. So adding the banner to OS9 Cisco was really not that hard, and it was my first touch into a module, which you literally just point X at the logo, load the link to the logo, you're going to do an output, and you call OS9 iWrite. There's three elements to the logo, the actual logo, the bottom part of the logo, and some drop shadowing for the color bar, and then the color bar. But that dropped in beautiful. Basic 09 was a 2-month curve for me with the lack of programming experience that I had at the time. And what I actually wound up having to do was figure out how to jump past jump vectors in the beginning Basic 09 to get executable code. So I had to byte balance the call to get to the end of it to pull my stuff. And so that was a big challenge. It taught me a little bit about how to print some stuff out to see where I was. So when I started, I did start, and it was going to continue to the banner, and I just printed out stuff because it would just crash. If I didn't get something, I didn't know really what went wrong. So that was a kind of a fun project by the time I got it done. The next thing, shell BG commands and shell BG off let you pull up bitmap background for your shell. And we went a step further and basically made some themes. And there's a file, sys background theme, that you put the name of the theme, like space or metal or wood. And basically, when you run the system, you get a start. So if you put shell BG in your startup, you wind up with the graphic startup.
And this is kind of the thing we talked about, the different layers, okay? Is you can have all this stuff going out and have your text going at the same time.
So a couple things about Basic 09. John and my feeling, it wasn't really ever extended for the OS9 Level 2 release. It was the same thing that was put out with Level 1. No enhancement. So everything we're doing really relies on Level 2. We're working from distributed source code. The original source code is tied up. We actually talked with Alan Banninger of Microware, but he doesn't have a contact at Motorola. He has the source code, but we can't get it cleared. So we're probably not going to get to look at it. But Basic 09 is a super powerful version of Basic. So Boise started work on Foenix Sim, a graphics 2 style subroutine module. He implemented all the screen controls, random seed commands, and it's DCF Midwest basically handed it to me and said, have fun. And that's what got me started with the whole Basic 09, extending this stuff. So one of the first things we're going to do, we're going to create a bitmap. We're going to clear the bitmap. We're going to draw a horizontal line, a vertical line, a circle, and a box. Pretty simple. Declare a couple variables. This one's important. It's the first map block of the bitmap. And the other thing is just a pause. But to simply call something, you run Foenix clear. That clears this text screen. You run Foenix bitmap, creates bitmap 0, stream type 0, returns the first map block to layer 0 on CLUT 0, and we load the color lookup table. Graphics on, we clear the bitmap. And if you look, you can see that we reference that BM0 when we clear it, because we could clear 3 different bitmaps. So that's actually telling it what bitmap we want to touch, 6 in there is actually the color, and then you see it also references BM0, so it's what bitmap we're drawing to. And we did the line, the circle, and then the box. Press enter, and then we turn off the bitmap, free the graphic resources, and then turn the graphics off. The mouse is super simple to use and basic. You just declare your XY, your button, clearing the screen, run Foenix mouse, XY button, and you're returning those values, print the column 0, row 28, and print out the values. And there you've got a simple mouse. To load a font, super simple. We've got 2 fonts, 0 and 1. All you got to do is tell it what font, path to the font, run Foenix, load font, and the font name. You can also make custom characters. So if you want to do games, if you want to write something custom, we can actually customize some fonts. And everything I did is pretty much integers other than paths in commands. But this one is special. It takes an 8-byte special type. So type FNC, that's my font. I mean, not to mention font character, then type FNC. And you look with a very modern looking programming environment.
I'm going to interrupt you just a moment because this is very important what you're doing, okay? You know, I may be assembly language through and some of the rest of us, but not everybody out there is not. This lets you access from basic and do this. So this is very important work he's doing, okay? And I wanted to point that out. You know, give him a pat on the back for that, okay?
Another really powerful thing, is one of the last things we got in, is mapping blocks into Basic 09. And I'll talk about this a little bit more here in a second, but essentially, what page do we want to map? And it will return the address that that page got mapped in. So run Foenix map block page, and the return address, I'm going to print them out. We're going to show you this in the demo. But the neat thing too is I could run shell commands from Basic 09. So we're just going to do a pmap and then pause and look and see where the page is mapped in, and then we're going to clear it. So here we are. You can see we ran it, page 193, and it mapped it in at 24576. If you look right there, you can see page C1 mapped in. And if you see down here, we cleared the block, we unmapped page C1. So why does this stuff matter? All this fancy hardware, if you look down towards the bottom in gray, and in the red block, that is the MMU page. So you've got bitmap registers, mouse, tile registers, sprites, graphic font memory, lookup tables for your color, graphic text memory, font color. Look at the sound section. All that in C4, there's just all kinds of sound. And in C5, there's all kinds of stuff. So you can get in here and kick the hardware around right with Basic 09, which is pretty neat. And I'm going to show you what happens when we create a bitmap. So we're doing an nmap before we ran it. We're doing an nmap after we ran it. And the bitmap took 10 8K blocks. So you can see that that's mapped in, and that's a result of running the bitmap command and allocating. So one of the things I did with map block was mapped in the text screen, this text memory. And you can take that for granted on the CoCo because you can just do it, but I actually had to map in the page. So we're going to try a little live demo. Alright, so when I hit enter, Basic 09 loads like fire on an SD card. I mean, it's super fast. You saw that. So what got me started on this was I wanted to do some mouse-driven menuing, and I really didn't intend to write a file browser. But we've got our little menu here. We can get to the root directory. We've got all our drives. You can select a drive. If I want to look at startup, for instance. I can just click on startup, and I get some extra options over here, so I'm just going to list it. We can also dump things. We can also transverse directories. So if we want to go look at the commands directory, and if we click on something, we basically ident it, because it doesn't make sense to run all the commands right now in the state I'm in. So anyway, it just does an ident. There are a few commands that I had in there that you can, we actually said, okay, you can run, but here's the Foenix module, about 4605 in size now, so there's quite a bit of stuff. I probably need to do some tuning and scaling down some code where I can, but anyway, still pretty neat. Probably shouldn't have listed the module. Anyway, let's go back. So I'm going to go out of the commands directory and come back up, and we're going to take a look at sys. So John put the fonts in, and I put the backgrounds directory in, but we can get in here, for instance, click on the tech font. I want to see what that tech font looks like. I get a preview. Go up the directory, we're going to go into backgrounds. And we can actually pull up preview of background. We actually got the Mandelbrot running. I'm not going to wait the whole time for it to draw, but that's the result.
And understand that most of this stuff he's doing on a text screen. Okay, so you have a mouse pointer that's a sprite, don't test the sprite, and you can use that on your text strings. So you don't have to be in graphics mode. You don't have to use all that memory for graphics mode to do it to have the mouse pointer.
So I don't have a bunch of time to sit and write basic 09 because I'm doing the calls, but somebody's got to test it. So paint was one way that I could test things. And this is left click to draw, right click to set a color off the palette. P gives you a plot mode where you can use the arrows to draw around. You can toggle on and off the help. But you can also load files from disk. So if you want to paint something up and load it, you can. This is pretty neat. I want to stop here and let you kind of take a look at the system. So we're running the file browser, and it's its own process sitting there. And then now we're running a basic program on top of that. And we've got a couple shells in there. But the neat thing is if you look at the top, all the map blocks for basic 09 are the same, other than that page C2 that I've got mapped in to read the text. So OS9 is super efficient, and you can really see it right here because it's right in front of you. You can see the reuse of executing code. So I'm going to type by, and I'm back to my file browser. You can also browse around like at the scripts. And basically at this point, I'm just going to be able to list things. But it proves that you can do a lot with this stuff. It's really neat, and this is, it's basic. It's not that hard code to get in there and do. So I really think that's what's pretty neat about the setup. So I'm just going to sync back up here, and we're going to take a look at the commands. Bar. Well, bitmap, BM clear is a bitmap clear, BM load, BM off, BM save, so that's all the bitmap stuff. Box, circle clear, clear block. Here's all your standard CoCo screen management commands. A couple more up at the top, some font commands, real-time clock, some more graphics, ID. We also built NKey in to the Foenix module because I really got to use every bit of memory possible to make things work with 64K. So we also have a mouse that returns 320 by 240, or a mouse HR which returns 640 by 480. We've got a peak word, a poke word, random. The sprites are the thing that we're working on now. John's working on some memory allocation. The commands that have There's 4 commands, basically loading a sprite, saving a sprite, etc. These are still in the works, but I can move one around, assign, create. So out of the 59 commands, we've got 55 of them. So that's pretty neat at this point. And John's work has just been fantastic because it helped me get started, and then at the same time got me going, and also got a lot of direction from it. If you're interested in stuff, the C256Foenix.com, if you scroll down to the very bottom of the page, there's a link to the Discord channel. So you can basically see what's going on, all of the stuff. If you really want to build a system, the second link is for you. It'll walk through all the technical details of how to build, how to do everything. And the basic 09 folder on the SD and the DriveWire images will have basic example code. So every time that we keep adding commands, there's example code in that folder. So if you get a new SD release, you're going to see new stuff. Anyway, that's what I've got. Thank you guys.
First of all, thank everybody. I want to give a thanks, and I think from the community, to Boise, John, and Massie for all the work they've done on this. Of course, to Stephanie for the hardware work she's done, and gives us another thing. You know, I looked at it, and I've watched this as far as I knew it was coming along, and Candy Assembly last year is up and running, and something is okay. This has a lot of things I've wanted for the Coco all along. Okay, it's got the time lapse. I do that in software in my games. And it's got sprites. Well, you know, I can do it in hardware. And so, it didn't take much convincing to get me going and working on it. I'm getting a lot of work done. Some of the things need to be done what they're doing. I'm going to build on their work. That's how anything gets done, and it has to recreate. But again, a very big thank you, guys. Thank everybody that came here, and we have our booths up, so we're going to have sessions. But, it's not quite ready for everybody just yet, but we're working on it. This is not the first time I've supported a new machine. I supported the MM1, so I've been through this before. This is actually a little bit earlier in the process of jumping in on it than what did on the MM1. So there's less there to work with. We'll get it there. We've got a good team here, and look forward to more people getting this and jumping on board with us. It's a great way if you want to do OS9, you want some power. It's huge, the stuff that Matt is doing for the basic, because again, you don't have to be that in some language program to be able to do some of this stuff. And that's very important. Thank you again. Thanks.